Hi students, the subject name is BE 8253 Basic Electrical, Electronics and Instrumentation Engineering. Today we will learn some basics of new topic. The new topic is mesh analysis and nodal analysis. Before that, last class we are discussed resistance connections. There are two types of connections, series connection and another one is parallel connection. In series connection, the for example two resistors are connected in series, that means and the total resistance, that means equivalent resistance is equal to adding the two resistance, that means R1 plus R2. Before that, the same two resistance are connected in parallel, means we have find the value of R equivalent is equal to R1 R2 divided by R1 plus R2. In series connection, the current will be same for two resistance, but voltages are different. In parallel connection, the voltage is same but current will be differ for each and every resistance. Okay, we will see the problem. 1. Calculate the equivalent resistance for the circuit which is connected to 24-volt battery, and also find the potential difference across 4 ohm and 6 ohm resistors in the circuit. In the circuit, the two resistors are connected in series. The two resistors are R1 is equal to 4 ohm and R2 is equal to 6 ohm. These two resistors are connected in series with voltage source. The voltage range is 24 volt. In series circuit, the current will same but the voltages are differ from each and every resistor. First we have calculate the value of R equivalent. R equivalent is equal to R1 plus R2 for series connection. So we have to substitute the value of R1 and R2. 4 plus 6 is equal to, we get the value of equivalent resistance 10 ohm. And next we have find the total current in the circuit. According to Ohm's law, V is equal to IR, I is equal to V by R. The total voltage already is given in this problem. V is equal to 24 volt and R, just now we have calculated that the equivalent resistance is equal to 10 ohm. So we have to substitute the values. V is equal to 24 divided by R is equal to 10. But 24 divided by 10 we have to calculate, and we have find the value of current I is equal to 2.4 amps. And next we have calculate the potential difference across 4 ohm and 6 ohm resistors. The voltage across the 4 ohm resistance, the formula is V1 is equal to I into R1. The value of total current is same for each and every resistor. R1 and R2 resistors, this current will be same. So I is equal to 2.4 amps into R1. R1 is equal to 4 ohm. So substitute the value. So we get the value of voltage V1 is equal to 9.6 volt. And next we have find the value of V2, that means voltage across a 6 ohm resistor. V2 is equal to I into R2. So substitute the values. I is equal to 2.4 amps, R2 is equal to 6. So we get the value 14.4 volt. And next problem, calculate the equivalent resistance in the following circuit and also find the current I, that means it's the total current, and I1 and I2 in the given circuit. In this circuit, given circuit, the R1 and R2, the two resistors are connected in parallel. So in the circuit, voltage is same for R1 and R2 but current is differ. I1, we have to separate the value of current I1 and I2. I1 is nothing but the flow of current in R1 resistor. I2 is entering the current into the R2 resistor. I is nothing but total current is equal to I1 plus I2. In this circuit, in this parallel circuit, we have find the R equivalent. 1 by R equivalent is equal to 1 by R1 plus 1 by R2. And finally we get the value of R equivalent is equal to 12 by 5 ohm. And next we have find the value of current I1 and I2 according to Ohm's law. V is equal to IR, I is equal to V by R. In parallel circuit, voltage is same, so I1 is equal to V by R1, I2 is equal to V by R2. So we get the value I1 is equal to 6 amps and I2 is equal to 4 amps. The total current I is equal to I1 plus I2, so 6 plus 4 is equal to 10 amps is the total current. And problem 3, calculate the equivalent resistance between A and B in the given circuit. In this diagram, the 6 resistors are connected in between A and B terminals. In first two resistors are connected in parallel, so we substitute the formula 1 by R equivalent is equal to 1 by R1 plus 1 by R2. We get the value R equivalent is equal to 1 ohm. And the next, and that 4 ohm and 4 ohm resistors are connected also parallel, and the next 6 ohm and 6 ohm resistors also parallel. So we have to apply the parallel formula and we get the circuit. Final circuit is A and B is the equivalent resistance of A and B is that 3 resistors are also connected in series, so we can add these 3 resistance. 1 plus 2 plus 3 is equal to 6 ohm. This is the equivalent resistance of the terminal A and B. And next one is, the next new topic is new analysis techniques. This is a new analysis techniques. There are two types, nodal analysis and mesh analysis. And this is not new technique. It is derived from KVL, KCL and Ohm's law. And nodal and mesh analysis simply allows us to identify a reduced set of unknowns which completely characterize the circuit, and also we can write and solve fewer equations and to simplify our new technologies, nodal or mesh analysis. Before that, we have learned planar network. Planar network is nothing but there is no crossing lines in between the circuit. In this network is a planar network. If that means if a network can be drawn on the sheet of paper without crossing lines, is said to be a planar network. In this example 1, there is no crossing line in between the network, so in this circuit is called planar network. And example 2, in this circuit there are two crossing lines are available, so in this network is not a non-planar network. In each and every mesh analysis you have to apply for planar networks. In nodal analysis is also planar network and non-planar network. It is applicable for planar and non-planar networks. First we are discussing about mesh analysis. Mesh analysis is nothing but loop current analysis. In this analysis we have derived from KVL. KVL is nothing but Kirchhoff's apply for voltage law. In a loop is a closed path in a network. In a given network, how many closed paths are available? First we have to determine the how many closed paths are available in each and every network. A loop means is a closed path in a network. And next one is important thing is loop analysis can be applied to a network. We must first check that is only one voltage source. That means it is a independent or dependent voltage source. And next one is current source must be transferred into its equivalent voltage source. In a given problem, it is voltage source means it's okay. If any current sources are available, it transformed into equivalent voltage source. Sometimes it's difficult task to identify the independent loops in a network. Okay, example 1, we have find the current I1 and I2 by using mesh analysis. In this given network, there are two closed loops are available, so we can write two equations in this. Consider loop 1 is nothing but the 12 volt battery and 6 ohm and 3 ohm resistors. These are the loop 1, and next one is 3 ohm, 4 ohm and 10 volt. These are the another loop 2. In 3 ohm resistor, in between the current I1 and I2, so we have write these equations, write the two equations by applying mesh analysis, mesh current I1 and I2. We have formed the matrix. Applying Ohm's law, V is equal to IR. In this above problem, there are two loops are available, so we get 2 cross 2 matrix. To form a 2 cross 2 matrix, R is nothing but resistance matrix, I is nothing but mesh current matrix, E is the source matrix. E is nothing but is another name of V, voltage, is a source matrix. We have to solve the equations by using Cramer's rule. We get the value of current I1 and I2. I1 is equal to 6 amps, I2 is equal to 4 amps. The current, to find the current in 3 ohm resistor is I1 minus I2. So 6 minus 4 is equal to 2 amps. This is the final answer for the given problem. And next one is nodal voltage analysis. Is a nodal voltage analysis nothing but dual of mesh analysis. In nodal voltage analysis, we have to apply KCL equations instead of KVL. KCL is nothing but Kirchhoff's current law. Current entering the circuit is equal to current leaving the circuit. We have take a one node is a reference node or datum node or ground node. In each and every node, assume to be a ground or zero potential. And next one is the equations are solved to give nodal voltages. That means I is equal to V by R. The current through any branch and voltages at any point of network can be calculated by using KCL. The each potentials of all other nodes are defined with respect to the reference node. These are the procedure of nodal analysis. Okay, thank you.